Good day, students. Welcome to your mathematics class today. Our topic for today is collection and presentation of statistical data. The lesson objectives. By the end of the lesson, students will be able to 1. Collect and record statistical data in a systematic way. 2. Analyze and interpret statistical data presented in tables. 3. Present statistical data in rank order and frequency table. 4. Present statistical data graphically using pictograms, bar charts, and pie charts. 5. Interpret statistical data presented numerically and graphically. Our lesson materials include our 3 textbooks. Contents. Introduction. Statistics, simply defined, is the study of information, usually in numerical form. Statistical data are basic information, usually numerical. The basic purpose for statistics is for prediction and planning. For example, given the statistics of students' population in a federal unity college in Nigeria from the year 2013 to 2018, use the statistical data in the table below to answer the following questions. What the introduction has said is that when you want to make predictions or when you want to plan, you need statistics. And this statistic can be given as information in numerical form. It is left to you now to know how to interpret this information in numerical form and use it for prediction and planning. Now let us look at this frequency table. The frequency table gives us the year 2013, 2014, 15, 16, 17, and 2018. The number of students, that is students' population, in 2013 is 1,361. 2014, 1,364. 2015, 1,399. 2016, 1,435. 2017, 1,470. 2018, 1,506. If you look at this students' population against the years under review, you find out that starting with a student population of 1,361, by 2018, the student population has risen to 1,506. We can make a lot of planning and predictions from this information, which is numerical. It can be that the students' population is increasing. If student population is increasing, what do? It may mean increase in number of classrooms, a demand for number of increase in number of dormitories, a demand for increase in number of teachers, and things like that. If you do not have these statistics, you cannot make that prediction, you cannot make the planning. So let us look at the questions that we are going to answer using this frequency table. So the first question is the school growing in size? The second one is, what is the difference in the student population between 2013 and 2018? 3. If there are approximately 40 students in each class, how many classes had the school in 2013? Number 4. In 1 year, the school started a new JS1 class. Which year was that? And number 5. In which year will that JS1 class be in SS3? So let's look at the solution. Question number 1, is the school growing in size? That is the population of students, is it increasing? The answer is definitely yes, because in 2013, student population was 1,361, but in 2018, student population was 1,506. So, student population is increasing. Question number 2. What is the difference in the student population between 2013 and 2018? So, student population in 2018 equal to 1,506 students. Student population in 2013 is 1,361. So, what is the difference? Difference in students population equal to 1,506 minus 1,361, giving us 145 students. Question number 3. If there are approximately 40 students in each class, how many classes had the school in 2013? Solution. Number of students in 2013 equals to 1,361. Number of students per class is 40. So, number of classes in the school in 2013 equal to 1,361 divided by 40, giving us 34 classes approximately. Question number 4. In 1 year, the school started a new JS1 class. Which year was that? Students population in 2016 is 1,435. Number of students per class is 40. So number of classes in the school in 2016 is equal to 1,435 divided by 40, giving us approximately 35 classes. All this while in 2013, 14, 15, the number of classes have been approximately 34 classes. But in 2016, the number of classes approximately 35 classes, which means that a new JS1 class was created in 2016. Question number 5. In which year will that JS1 class be in SS3? Already in 2016, the class was in JS1. So they've completed JS1 in 2016. So to get to SS3, they need extra 5 years. So you add these 5 years to 2016, and you will have 2021. So in year 2021, that's JS1 created in 2016, the students will be in SS3, getting ready for their SSCE. You can see from this frequency table given, a lot of predictions, a lot of planning will be used using that table, and that is all about statistics. Example 2. A police officer made a note of the first 100 vehicles that passed on a road. The numbers of each type of vehicle are given in this table below. Vehicle, the types of vehicles are lorry, bus, car, taxi, motorbike, and bicycle. Numbers. The numbers of lorry that passed within that time under review is 7, bus 0, car 28, taxi 2, motorbike 15, bicycle 48. When we have in this frequency table bus 0, it means that the police officer didn't see any bus. That is the implication of the 0. It doesn't mean that there was no type of bus. Bus is a vehicle, but within the time under review, the police officer did not see any bus. So questions on this frequency table. Number 1, nearly half of the vehicles were of one kind. What were they? 2, how many vehicles had only 2 wheels? 3, how many cars were there for every one lorry? 4, which was the third most common type of vehicle? 5, how many buses did the police officer see? 6, is it true to say that buses never go on the road? 7, is this road more likely to be in a big city or in a small village? Give reasons for your answer. Let's look at solution number 1. The question says nearly half of the vehicles were of one kind. What were they? Nearly one of the types of vehicle was of one type. Here, looking at the frequency table, lorries were 7, no bus, cars 28, taxi 2, motorbike 15, bicycle 48. So the answer is 48. Question number 2 says, how many vehicles had only 2 wheels? In the vehicles seen by the police officer, how many has only 2 wheels? We have motorbike, we have bicycles and motorbike. Question number 3, how many cars were there for every one lorry? One lorry, you have 7 lorries against 28 cars. The question now says, how many cars were there for every one lorry? 4 cars for one lorry, because we have 28 cars for 7 lorries. 7 divided 28 gives us 4, and 7 divided 7 gives us 1. Question number 4. Which was the third most common type of vehicle? Third most common. The first is bicycle with frequency 48. Second is car with frequency 28. And third is motorbike with frequency 15. Third most common should be motorbikes. Question number 5. How many buses did the police officer see? How many buses? The police officer did not see any bus because the frequency of buses is 0. He didn't see any bus. None is the answer. Question number 6. Is it true to say that buses never go on the road? The answer is no. We cannot say that buses don't ply that road, but the police officer did not see any within the time of data collection. Within that period of data collection, the police officer didn't see any bus. It doesn't mean that buses don't ply that road. Question number 7. Is this road more likely to be in a big city or in a small village? Now let's look at the frequency table again. If this road were to be in a city, a big city, we will see taxis, we will see cars more than seeing motorbike and bicycles. Yes, because in a big city, taxis are used frequently, cars by workers and so on. But in this frequency table, we have taxis 2, we have cars 28, but we have motorbikes 15 and bicycles 48, meaning that this road most likely will be in a village setting. So you can see how important statistical data is. Like in this last example we have looked at, many questions can be asked. A question may even be asked, are you sure that road is good, is pliable? Then it may, the frequency table will give us that information. So what do we do if it is not pliable? Why don't we have many cars? Why don't we have many buses? It can be that the road is very bad. So planning comes in to grade the road, make it to be usable, motorable, and things like that. It can be that the road is not safe. So what will be the planning? The planning will be put more security men and things like that. So statistical data is very informative. It helps us when we want to plan. It helps us to predict the future, and it now helps us to do things better. So the next topic now will be presentation of data. One is to collect data, but how do you present this data to be understood by people that want to use it for prediction and for planning? Good presentation of statistical data makes it easy to read, understand, and interpret. There are two major ways of data presentation. One is lists and tables. Examples are rank order list and frequency table. Two is graphical and pictorial presentation. Examples are pictogram, bar chart, and pie charts. So we will now take these examples, the list and tables, and then the pictorial presentations. I just hope you are following in all we have been discussing under collection and presentation of data. So the first one, lists and tables. One, rank order list. Rank order list means to present statistical data in order of magnitude from the highest to the lowest. An order of magnitude are ascending order or descending order. When we look at the order of magnitude in ascending order, it means that we are starting from the lowest to the highest. If we are talking about descending order, it is from the highest to the lowest. Either way is rank order list because it has been arranged. The statistical data have been arranged in order of magnitude. And two, frequency table. This means the number of times something occurred. Frequency means the number of times something had happened, the number of times something had occurred. Grade A had occurred 3 times. Therefore, the frequency of grade A is 3. Grade C had occurred 2 times. The frequency of grade D is 2. Frequency table is a table that now shows the number of times something occurred. Examples. A mathematics teacher gave a test to 15 students and graded the scores from A, very good, to F, very poor. The grades of the 15 students are as follows: B, C, A, B, A, D, F, E, C, C, A, B, B, E, B. The question says, present this data in 1, rank order, to frequency table. Recall that rank order means arranging a statistical data in order of magnitude, maybe in ascending order or descending order. And frequency is a table that shows the number of times something happened. So, solution. In rank order, the grades will now be A. Why? We have A1, we have A2, we have A3. So they occurred, A occurred 3 times. A. Remember, each grade must be represented. You don't say just A. You say A into the number of times. Then B occurred how many times? 1, 2, 3, 4, 5. We have 5 students scoring, coming out with the grade B. You show 5 students. B into 5 places. 1, 2, 3, 4, 5. Then C. We have C, 1, 2, 3. 3 students got grade C. We present it C. D. How many students? 1. Only 1 student got grade D. E. How many? 1 and 2. E and E. F. How many? Only 1. So this is a list, a rank order list, showing the students' performance from very good, A, to very poor, F, and the number of students. Now, when you have presented a statistical data using rank order list, if you count the number of students or color or age, whatever is the item you are representing, it will give you the total number of people or things that you have in the question. What do I mean by this? The question says test was given to 15 students and 15 grades were received from the 15 students. So in the rank order, you should have 15 grades. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is the check. It is wrong for the student to say A had occurred 3 times. Oh, we have A. Then B occurred 5 times. We have B. C 3 times. We have C. And what you are saying is still that you have presented in rank order from highest to lowest. Yes, it is from highest to lowest, but you did not show all the grades in the question. So they must be equal to the number of students, and this is the only rank order that is correct. 2, frequency table. We have the table, first row, grade. In grades we have grade A, B, C, D, E, F. The frequencies. For A, we have 3. 3 students got grade A. 5 students got B. 3 students got C. And 1 student got D. 2 got E. And 1 student got F. The questions now. Which grade did most students get? Remember, frequency means the number of times something occurred. So, which frequency is highest there? It is 5 for grade B. The answer is B, grade B, and not 5. 5 as the frequency is helping you to know that 5 students got B grade. So answer is B. How many students got above grade C? How many students got above grade C? Grade C is not inclusive. Above grade C. So how many students? A had 3, B 5. So how many students got above grade C? They are 3 plus 5, 8 students. How many students performed very poorly? Remember that the test results have been graded from very good A and very poor F. So how many students performed very poorly? Answer is just 1, F. E, how many students got below C? Below C. C is not inclusive. So below C, we'll have D, E, F. So how many students? 1 plus 2 plus 1. That would be 4 students. What percentage of the students got B? Percentage of the students that got B. How do we get that? We look for the frequency of grade B. It is 5. How many students do we have that took the exam? They are 15 students. That's what the question says. So percentage will be 5 for frequency of grade B over 15. Total number of students times 100 over 1. And that gives us 33 1/3%. We have students, the grades A, very good, to F, very poor. Now, looking at the frequency table, we have people, C is the middle, and we have just 4 students below C. So our answer, in our opinion, is that yes, many students did well because 11 students out of 15 students got C and above. Students, you can see how many questions that can be answered using one frequency table. We can go on, we can find percentage, we can find products, we can find decimal fractions of things, and that will help us in planning. For example, another question can be, is, in your opinion, that class, does it have a good mathematics teacher? Yes, because the students are doing well. If the students have not done well, the question can be, do you advise the school to get a new teacher for the class? That becomes planning. So many questions can come under statistical data. So we come to the subtopic, graphical presentation of statistical data. Most often, a graphical or pictorial presentation of statistical data will give a clearer meaning. Examples of this include pictogram, bar chart, and pie chart. That is examples of graphical or pictorial presentation of statistical data. Let's look at the examples one by one. 1. Pictogram. A pictogram uses pictures or drawings to give a quick and easy meaning to statistical data. However, the pictures or drawings used must resemble the data to be presented. If you are talking about trees, the statistical data you want to present is trees, and you begin to use the pictures of a human being, or pictures of cars, or pictures of houses, it will not resemble the data you want to present. So if you are talking about vehicles, you should use pictures of vehicles, of cars, of buses, of motorbikes, of bicycles to resemble the data. That's what is the important thing you must note in pictogram.